In the previous video and the previous part, we have dealt how to differentiate questions like these ones. We did question 3, question 2, how to use quotient rule. At this point, the question 1, we are supposed to use product rule. And then we also learned how to find the stationary point and determine whether the stationary point is a maximum or a minimum. Remember, we say that if you find the derivative of that function and you find the second derivative of the function, it will mean that if d squared y dx squared is greater than 0, it means that's the minimum point. If you get a negative number, it means that's the maximum point. Here we used quotient rule in order to work out this. You can check in the previous video if you have not watched that. At this point also, we differentiated using product rule and then worked out the x coordinate of the stationary point. Now this brings us to question number 4, whereby we're going to focus on how to obtain the expression for dy dx, show that this can be written in the form x squared x a plus b sine 2x into x e to negative 4x, where a and b are actually constants. So when we look at the original equation given, we just notice that this is a product of two functions. So meaning we are going to use product rule in order to work it out. So let us go straight ahead and try to work out this question. And we shall begin by writing how the function was given. The function was given y equals to, the function is given as y equals to e to negative 4x, and then we have tan x. So we shall start by saying that our u in this is e to negative 4x, and our v in this case is tan x. Because when we're going to apply product rule, we are going to make use of dv, and actually we are going to make use of du. So it's wise at that point that we can be able to find our du dx. Du dx is going to be equal to, when you are differentiating exponential functions, what you do, you differentiate the top and you get the answer. And differentiating 4x, negative 4x, we're going to get negative 4. Then you write the exponential function the way it was given. That is how you differentiate this kind of exponent. And when we are differentiating tan, if you look at tan, if you differentiate tan, we are going to get dv dx equals to sec squared x. Now, product rule states that if you have two functions multiplied together, like for instance, we have u multiplied to v, then the answer to this is going to be u dv dx plus v, then du dx. So that will mean that we can be able to substitute what we have here, and then because already we have done the big part of it of differentiating, so meaning that we can write this is our u is actually e to negative 4x, so that's e negative 4x times dv. Our dv is this, which is sec squared x, then plus v du. So our v is tan x, and we had gotten our du dx, which is this part, and that's going to be actually times negative 4 e to negative 4x. Now, remember, you have to look at the way the expression was actually given. The expression was supposed to be given in the form of sec squared x into a plus sine 2x. So At that given point, we can try to see what can we manipulate at this point in order to have that. So I can be able to factor out. Okay, before I factor out, I need to appreciate the fact that tan x. How can we write tan x? Tan x is actually tan x can be written as sin x over cos x, but I'm targeting to have 2 sine. I'm targeting to have I'm targeting to have sine 2x. So for me to get sine 2x, I need to have cos x here. Then since I've introduced cos there, I'll also say cos x because that effect now has nothing. So which means that this tan x can be given as sine x cos x is equivalent to what? Is equivalent to sin x cos x over cos squared x. And this means we can say this is sin x cos x times sec squared x, because 1 over cos squared x is actually sec squared x. So we can now replace whatever that we have gotten at this point. We just put it at this level here. And I will just start by saying this can be written as e to negative 4x sec squared x. I need to write this properly so that it can be feasible. This is sec squared x. Then this will be minus 2 times, because we are having 4 here, so I'm going to say it's 2 times 2, but I need now to write that sine x cos x. Then I have exponent. Okay, sine x cos x, then sec squared x, then I have my exponent negative 4x. So what I've just done here, I've replaced tan x with whatever we had gotten in this side after showing here. But because I need to have sine 2x somewhere, but I decided now to split the 4 that we have so that it's in its 2 factors, 2 times 2, which is going to give us 4. And we are going to appreciate the fact that this part that we have here is actually equivalent to sine 2x. So that's the main reason as to why I did all these shenanigans, and then I can be able to plug it in. So our equation therefore can be given as exponent minus 4x sine square, no, this is a sec. This is sec squared x minus 2 sine 2x. Now we are saying this part that we are having here can be replaced with this, and then we have our sec squared x exponent negative 4x. Now, at this given point, we can now start factoring things out so that we can be able to give the equation in the form it was expected at this particular point here. And then we can now say we can factor out sec squared x. This is going to be sec squared x into bracket 1 minus 2 sine 2x, because on the other side I'm going to factor out exponent negative 4x, and that is now the form that we are supposed to give our answer in. Now at this given point we need to go straight and try to see the next question, because we are supposed to now, hence you are supposed to find the stationary point for that. already we have gotten our expression for the derivative or dy dx is this one. Then now we can be able to go ahead and find the stationary point for x. So I'll just leave this part that we have gotten down here, and we are going to say now that since our dy dx is equal to sec squared x into 1 minus 2 sine 2x exponent negative 4x is equal to 0 at the stationary point. So we can now say we can at stationary point dy dx of a function is usually equal to 0. So at that point we can be able to conclude and say definitely this is going to be sec squared x into 1 minus 2 sine 2x exponent negative 4x is equals to 0. So at this given point, we have all the right reserved to us and say that we have three parts of this equation. And therefore, we can be able to say the first part, which is sine sec squared x, can be equal to 0. So we can say the first equation, sec squared x, can be equal to 0. We can also say 1 minus, okay, let me just leave that one there. I write exponent minus 4x is equals to 0. And we also can say minus 1 minus 2 sine 2x is also equal to 0. So if you can look at this part that we have at this point, actually sec squared is can be written as 1 over cos squared x. That is how what sec means, is equals to 0. So in order to find the reciprocal, we are going to get at a point whereby we are saying that if we find the reciprocal, this is going to be cos. Okay, at this point we can say there's no number. You can be able to divide 1 by in order to get 0. So we can say here there is no solution, no solution, no solution, because there's no number where you can say 1 divided by that number to get this. So at this point, we can say we are not going to continue with that. And this one here, there's no number you can be able to raise by an exponent in order to get 0 as well. So at this point also we say no solution. So we are going to be left with one option whereby we are going to go ahead and try to use this one in order to get the value of x, because we are finding the exact x coordinate, and that's going to be 1 is equals to, by taking this on the other side, we shall have 2 sine 2x, and this means 2 sine 2x is actually equal to 1, whereby we are going to divide by 2, and we end up having sine 2x is equals to a half. Now, but remember, x value was given in the range from 0. Let's try to check the way the range was given. Was given from x is we were given x is greater than or equal to 0, less than or equal to a half pi, a half pi. So having given that, and if you look at the equation the way we have it at this given point here, you notice that we are having 2x at this point, and yet here we are having 2x, but here we are having x. So meaning we can now increase the domain of x by multiplying by 2, and then the new domain is going to be 2x is greater than or equal to 0, less than or equal to pi. So whenever we are going to solve our angle, we are going to work it within this particular domain, and so we are going to say this is going to be 2x is equal to the sine inverse of 1 over 2, and that is going to be, actually, if we can be able to use our calculator, and remember your calculator has to be in radians, I'm getting 1 over 6 pi. I'm getting 1 over 6 pi. So we need to find, remember at this point, this is sine 2x equals to 2, so is equals to a half. So meaning we are finding where sine is positive. So it will mean that all students trust Cambridge, but our angle that we have gotten is actually 1 over 6 pi. And then it means for at which quadrant do we have again sine being positive? That is also in the second quadrant. So which means that we can be able to find that angle also in the second quadrant. But if this is 1 over 6, because of uh, this angle is 1 over 6, this is going to be also 1 over 6 pi. But since we were finding positive angles, then the next angle we are going to find is this angle that runs up to this given point. Now, to get the angle at this given point, it will be pi minus 1 over 6 pi. So the second angle, so we have said that our first angle is 2x equals to 1 over 6 pi. And the second angle will be 2x is equals to pi minus 1 over 6 pi, which is coming from this given point here. And then definitely at this given point, we're going to get 2x is equals to 5 over 6 pi. And at this given point now, for us to get x, we are going to divide this by 2, divide by 2, and also we are going to divide this by 2, so that we are going to have this as 1 over 12 pi, and this other one is going to become x is equals to 5 over 12 pi. So those are the two, and I think it's not really clear down here, especially this part. I need to write it somewhere you can be able to see. So here it's going to be 2x equals to 5 over 6 pi. Now to get x, we are going to divide this by 2, and then we are going to get our answer being 5 over 6. Rather, we are going to get our answer here 5 over 12 pi. So those are the two solutions you are expected to get in this particular question. Now this also brings us to the next question of interest. Now, the next question of interest is the question whereby you are going to differentiate tan squared. And just look at that. Question 5, the equation of the curve is given by y equals to e to negative 5x tan squared x. So how are we going to approach this particular question at this given point? So meaning at this point, we are going to again use product rule, because we can see that we are given y equals to e to negative 5x tan squared x, which will mean that our u is going to be e to negative 5x, and our v is going to be tan squared x. So how do you differentiate? Because we're going to use product rule, and the reason is these are two functions multiplied. So we are going to say our du dx is going to be negative 5 e to negative 5x. We said if you are differentiating an exponent, you differentiate the top, you bring it behind the exponent, and then you write the exponent the way it was given. Then we also have to find the v dx, which is going to be equivalent to, okay, so this one, it can be written as tan x then squared. Now we are going to have or we are going to make use of chain rule, at this point. Because there is a power, we are going to differentiate using power rule and just assume this function inside and say this is going to reduce, we take the power down and we maintain the function inside the bracket the way it is. Of course, when we take the power down, we're going to decrease the power by 1, and that's going to be actually 1 at the top. Now, once you have done that, now you go to the inner function. You again differentiate it without looking at the power, and that's going to be sec squared x. So, using product rule, we know that product rule is uv is actually u dv dx plus v du dx. So that will mean that our u is actually this one. So, and that's going to be negative 5x times our dv dx, which is going to be 2 tan x sec squared x. Then we are going to say plus v, our v is actually tan squared x, and our du dx is this part, which is times negative 5e to negative 5x. So this is going to simplify to 2e negative 5x tan x sec squared x minus 5e to negative 5x tan squared x. So because in this question we were just supposed to differentiate and get the derivative dy dx. So this is our final dy dx. Maybe if we are supposed to factorize out things and to make the examiner happy, we can just say this can be written as what? This can be written as a, okay, we can see there's tan x, there's also tan x here. We can be able to say this can be written as tan x a to negative 5x to sec squared x minus 5 tan x. So of course this step is just to try to make things cleaner, but it's not really necessary because you are not told in the form you are going to leave your answer. So basically that's what you are supposed to do whenever you are doing differentiation in math 3, that is P3. You need to understand how to use quotient rule, how to use product rule, how to differentiate exponential functions. You need also to know how to differentiate trigonometric functions. So this is not all, but this is just some of the part that you ought to know, because whenever you are going to do an exam, you'll be expected to do differentiation. So some of those basic knowledge of differentiation is required, especially differentiating exponents, differentiating polynomials, differentiating trigonometric functions is highly required, because you cannot be able to proceed to solve an application question like those that you are told to find the minimum point or the stationary point if you really don't know that. So as you are preparing for your exam, make sure you have all those basics, and then now you must immerse yourself into past papers in order to know and try to have a feeling how are question asked and how do you approach them. So in the next series, we're going to do and see how do you do parametric differentiation, because in this course also there's another technique you can be able to learn on how to stick in Propland YouTube channel, so that whenever I'm going to upload that particular part, you'll be notified. We are going to have a series that's going to run through all the topics that you are expected to learn. So this is the beginning, and I believe you'll have a reason as to why you ought to subscribe, so that whenever we are going to upload more tutorials, you'll be notified.